Okay, so now we're going to actually find that p-value. We're going to construct a full FRQ with labeling, defining the parameters, stating your conditions, finding your p-value, and then being the judge and making that decision onto whether you're going to accept or fail to accept your H sub O. All right, so today is going to be all proportions. So P's, P hats, LCC. No X bars, no mu's, no CLT. Okay. So the title of what you're doing, you are a one sample Z test. The four proportions part is, for the most part, optional. The Z implies that it's proportions, but it doesn't hurt to get in the habit of writing that for proportions. The biggest thing is that you're a one sample, because when we get to chapter 10, we'll be two samples. So we are a one sample, Z because we're proportions, and test, not interval. I'm not doing a confidence interval. I'm conducting a test with a null and an alternate. Speaking of the null and the alternate, here they are. Remember that your null and your alternate are always in terms of the parameter. So the parameter for proportions is P. So P equals whatever your null hypothesis is. And then your alternate hypothesis will either be greater than, not equal to, or less than whatever the alternate hypothesis was. You still have to be random, independent, and the large counts condition helps you be normal. NP and NQ, we're going to look at our data and see if we need hats or not. We're going to base it off of the information that we're given. If we're given population information, then no hats. If we're given sample information, then hats. All right. Now, this guy is not new. This is this formula. This is on your formula sheet. Test statistic equals stat minus parameter over standard deviation of statistic. We used this way back in the day when we were finding z-scores. All right, so you're going to find a z-score. Statistic, p hat, minus parameter, p, over standard deviation of statistic, which is the square root of PQ over N, which I must know because I know P. Remember, you always want to use population information over sample information if the population information is provided. Okay, your P value is the area using your test statistics. So you just found a Z. So now what you're going to do is you're going to use that Z to cut your normal curve. If the alternate hypothesis is greater than, then you will be right-tailed because it's greater than, so that makes sense. If it's less than, if your H sub A, if your alternate is less than, then you're going to be left-tailed. It also means that your Z will be negative. And for right-tailed, your Z will be positive. Now, you don't have to make that decision. It will come out here in this formula as either positive or negative. But if you're greater than, then it will be right-tailed because it's going to be farther to the right. Remember, 0 is in the middle. And if your alternate is less than, you're going to be left-tailed, which means your Z should have been negative. Now, here's the part that's tricky. If you're not equal to, then you are two-tailed. Here's the problem. You're going to solve using that formula up yonder, and you're going to get a Z. And that Z is either going to be positive or negative. If you're two-tailed, it could be either. So what you're going to have to do, guys, is you're going to have to find this area if you get a positive Z and then double it to make sure you get that area down there. If your z turns out to be negative, then you're going to find this area first, the left-tailed area first, then double it to also include that area. So when it's not equal to, this is the tricky one, it is two-tailed, which means you're going to use the z that you get, so let's say positive 2.971, then I know I'm over here. So I'm going to normal CDF from 2.971 to infinity, comma 0, comma 1, and get my area. But then I've got to remember to double it because I've got that area down there. Because I'm not equal to, which means I've got area on both sides. Because it's not specifically greater than or less than. If your z pops out to be negative, then I know that it's the z down here, south of 0. So I'm going to normal CDF from negative infinity to negative 2.971, comma 0, comma 1, get the area, but then I'm going to double it because I got to go include that area there. So the key there is those two pieces, those two tails are the same area. You are just going to find one of them and then double it. So if you're right-tailed, then you're going to go from your z-score to infinity. Because you're right-tailed, you're over here. So you are finding this z with that formula up above. That number is going to go right there. And then you're going to infinity, 0, 1. If you're left-tailed, you're going to normal CDF from negative infinity to your z, which is negative, comma 0, comma 1. If you're, oh, this should not say right-tailed. This should say two-tailed. If you're two-tailed, and your z turns out to be positive, then you're going to do 2 times the normal CDF from your positive z to positive infinity. But if you're two-tailed and your z turns out to be negative, then you're going to 2 times your normal CDF. Now remember, your z is negative, so you're on the left-hand side. So from negative infinity to your negative z, comma 0, comma 1. You won't do both. You'll either do what's in purple or you'll do what's in green. So you're finding one of the tails and then you're doubling it because it's two-tailed. To test, you can either compare your test statistic to the critical z using your alpha, or you compare your p-value, to your alpha. And I will show you how to do all of that. Okay. So we have laid the groundwork. We are going to do three FRQs. Here we go. A basketball player claims to make 80% of his free throws. We thought he might be exaggerating. In a simple random sample of 50 shots, the player made only 32. Carry out a significance test. When I'm reading, whether I'm taking one of my tests or an AP test, when I see that word test, I know I'm H sub O, H sub A. That's the word you're looking for. So this is not a 95% confidence interval. I'm looking for a significance test. All right, they're giving me my alpha at a 5% significance level. Okay, number 1, state what you are. I'm a 1 sample. These are proportions. So I'm a z test, not interval, for proportions. Nope, spelled that wrong. Okay, the other house cleaning thing that you need to do is define your parameter. Okay, again, this is proportion, so my parameter is a p. We are making free throws, so it is the true proportion of all free throws. Okay, now if I stop right there, that's not a proportion. The true proportion of all free throws. That's like saying the proportion of all cars. If it's a proportion, it's got to be the true proportion of all free throws that he makes. It's the true proportion of all cars that are red. all his free throws is your capital N. I want the proportion of those free throws that he makes. That's what makes it a P. All right, so now I've got my conditions. So tell you what, pause me and go do your conditions. This is a proportion. So go knock out your 3 conditions. It is the same as Unit 8. When you're done, hit play. All right, conditions. Random, simple random sample. Independent, 10% condition, little n, big N, little n was 50. All right, now big N. Now again, this is not P, this is my population. So these are going to be all his free throws, not all the free throws that he makes, just all his free throws. Normal, LCC. So I need to decide if I need hats or not. It says a basketball player claims to make 80% of his free throws. That's a mothership statement. Now, in the sample, he made 32 out of 50. That is a P hat. So let's make sure you understand here. Your P is 80%. Your P hat is the 32 out of 50. Mothership is the claim. Sample is the sample. It's the data from the sample. So since I have mothership information, then on my LCC, no hats, ladies and gentlemen. So let's see, 50 times 0.8 and 50 times 0.2. That turns out to be 40. Good there. Oh, look at this one. That's 10. Oh, by the skin of your teeth. Just barely. So, does the equal to on the LCC make a big difference? Yeah. Okay. Now I've done my conditions. Now let's state the purpose of what we're doing. I need a null and an alternate. And if you want to do your null and your alternate before the conditions, that's fine. Don't do anything before these 2 housekeeping items. Do those 2 things first. Then you can do your null and your alternate, or you can dive into your conditions. Either way. So null, alternate. My null, now remember the null and the alternate, your hypotheses are always using parameters. So no hats on your P's. So P, now he claims he makes 80%. Now for your alternate, you don't change the 80. So I'm not touching the 32 over 50. I'm just saying I think he's exaggerating. So therefore I think it's less than 80%. Okay. Now, once I've done that, this is kind of like when you do an interval and you do all this prep stuff and you're like, oh crap, what do I do next? Well, that's when you go to your formula sheet and you are doing a test. So you are looking for a test statistic. Again, words, letters, numbers. Here we go. Words. Test statistic. Stat minus parameter over standard deviation. Okay, letters. Well, your test statistic, since this is a Z test, it's going to be a Z. Now guys, when we switch to means, that's going to be a T. This is not a Z star. This is not a critical value. This is a test statistic, so this is just plain old Z. All right, now, stat. That's him. Oh, sorry, I can't put in numbers yet. So sorry. P hat minus parameter P over standard deviation, which is the square root of PQ over N, no hats, because I know what P is. P and Q always default to mothership information. You only scratch that and put hats on it when you don't have that information. All right, so now let me put some numbers in here. Z equals, all right, P hat is 32 over 50 minus my P is a 0.8 square root of 0.8 times 0.2 over, what was my sample size? 50. Now, guys, I'm going to go ahead and tell you now, y'all learn from those who have fallen before you. Down here, I get a lot of this. I get a lot of 32 over 50 and then 18 over 50 for your P and your Q. But remember, if you know mothership information, then always use that in your standard deviation. Okay? All right. Now we're going to take a second and we're going to type this into our calculator because it would suck to get this formula right, but not know how to type it in. So pause me for a second and type this in. Now guys, when you type this in, I want this typed in one swoop. So I don't want you to do pieces, because if you do pieces, you start topping decimals, and that's going to drastically affect your answer. Okay, so I'm going to pull my calculator up so you guys can see how I type it in. All right. So here I go. I have to corral the top in parentheses because it's multi-termed. So 32 divided by 50. Don't close your parentheses. The parentheses is for the entire top. Minus 0.8. Close my parentheses. That's the whole top. The reason I need that in parentheses is because I'm about to divide it, and I'm trying to tell my calculator that that whole thing needs to be in the numerator. Now my denominator is one term, so I do not need parentheses around my denominator. So I'm going to go straight to my square root, and then I'm going to do 0.8 times 0.2 divided by 50. Now notice, I did not use parentheses. Well, that's because my calculator knows the order of operations, and when it's glued together like this and with multiplication division, it's going to go from left to right. Well, I want it to multiply these two before it divides by 50. Now, if that bothers you and you want to put parentheses around the top, you can, if that makes you feel better. And then I hit enter. That, my friends, is my z-score. That makes sense as a z-score because remember your z should be between a -3 and a +3. It could go just beyond a 3, and technically it could go up to a -4 or +4. But if you get here and your z-score is a 12.6, something's wrong. Think about what these numbers are. Make sure it makes sense because a lot of times that can help you catch a careless mistake. Your z-scores or your t-scores should be between a -4 and a 4. And anything beyond a -3 and a 3 is special. So -2.8, -2.828, if I'm going 3 decimal places. -2.828. Z equals -2.828. Now he's negative. Should he be negative? Well, I'm left-tailed. So absolutely he should be negative. So that should make sense. Hold on one second. All right. So now what I'm going to do is I'm going to use that z-score to find the area less than this z-score, or that not z-score. Yes, this z-score. So watch. I'm going to draw my curve. There's 0. So -2.828 is way down here. You're labeling. Everybody's drawing. Everybody's labeling. I want the area to the left of that. And that area is my p-value. Remember, the p-value is the probability that something happened by chance. It is a probability, so it makes sense that it is the area under the curve. So I'm going to normal CDF from negative infinity to negative 2.828, comma 0, comma 1, because these are z-scores, and the mean and the standard deviation will always be a 0 and a 1. I'm going to type that into my calculator, and I get, not a z, and I'm going to label him. This, my friends, is your p-value, and it equals 0.00234. Now, I'm going to very calmly state that you have to be accurate to 3 decimal places. However, I think that decimals that start with a 0 are trash. So go 3 decimal places of meat. So for this one, I went 5 decimal places because it started with 2 zeros. Okay? All right, I now have my p-value, like what they just flat out gave you in 9.1. You now found it from scratch. Now what do I do with that p-value? I need to compare it to my alpha. Well, my alpha was 0.05. And that p-value is less than that alpha. So remember what we drew in class. There's alpha. We reject H sub O if your p-value is below your alpha. So here comes the rubber stamp sentence. I'm going to type it. Now, feel free to just sit and absorb it and then pause it so that you can write it. All right? But here's your sentence. Since our p value, please notice that p is capitalized, because if it's lowercase, it's a proportion. Since our p value is less than the significance level, and this is where I would draw the Jesus fish. I'm just going to write A because I don't have a key for that. We reject H sub O. So your first sentence is, are you going to reject it or are you going to fail to reject it? And it is always your H sub O. So we are going to reject H sub O. But I'm saying why? Like, I'm not just saying I reject H sub O. I'm saying since the p-value is less than the significance level, alpha, we reject H sub O. Now you're going to have a sentence about evidence. Remember, your evidence sentence is always about your H sub A. So since I'm rejecting H sub O, that means I'm going with H sub A. So that means there is enough evidence. There is enough evidence to conclude that his free throw percentage claim is exaggerated, and he actually makes fewer than what he claims. So notice I didn't just say there is enough evidence to conclude H sub A. I have to state it in context of the problem. So your first sentence is kind of very like sterile and kind of formula, but your second sentence is more in context of the problem. There is enough evidence to conclude that his free throw percentage claim is exaggerated and he actually makes fewer than what he claims. Now, you could have simplified that and said, there is enough evidence to conclude that he makes less than 80% of his free throws. That would have been totally fine. And that's more succinct to what H sub A is saying. H sub A says he makes less than right here. He makes less than 80% of his free throws. All right, so that's your second sentence. Now, since this data caused us, important word, to change our opinion, to reject something and cling to something else, then this data made us change our mind. So this data is statistically significant. Okay, so the data is statistically significant. I can't talk and spell at the same time. The data is statistically significant. If there wasn't enough evidence to conclude H sub A, and I stayed with H sub O, then we would say there is not enough evidence. So the only word you would interject is right here. You would write the word not. And you would state that the data is not statistically significant. So that's your rubber stamp. Either with nots or without. And either with a reject or a fail to reject. Or you could say accept. All right. So there it is. There is your full-on FRQ. You've got your two housekeeping pieces. You've got your conditions, which by now you should be able to do in your sleep. You've got stating your null and your alternate. Then you've got your words, your letters, your numbers. Then you take that z-score and you put it on a curve and you find the area, and that is your p-value. Then you compare your p-value to your alpha and draw your conclusion. And that, my friends, is how you conduct a significance test. Let's look at another one. And imagine that it's about potatoes. It's the same potato chip producer from 9.1. He's just gotten another truckload of potatoes from its main supplier. Recall that if the producer finds convincing evidence that more than 8% of the potatoes in the shipment have blemishes, the truck will be sent away to get another load from the supplier. The supervisor selects a random sample of 500 potatoes from the truck. An inspection reveals that 47 of the potatoes have blemishes. Carry out a significance test at a 5% significance level. What should the producer conclude? Okay, so what I'm going to do first is I'm going to help you get all the math out of all those words. And then I'm going to turn you loose. I want you to pause me, and I want you to do as much as you can, and then hit play and check yourself, and then pause me and keep going. I don't want you to do this with me. I want you to do this ahead of me. But before I do that, let's get all of our data out of here. So I have a sample of 500 potatoes. So I know that N is 500. An inspection reveals that 47 of those 500 have blemishes. So P hat, alpha, 5%, and mothership is 8%. P is 8%. Okay, pause me. Do your two housekeeping things, do your conditions, see if you can get your test statistics, see if you can find your p-value, write your null and your alternate, and write your conclusion. Like, see what you can do without me, and then hit play. All right, this is a one sample Z test for proportions. Proportions calls it to be a z-test. If it was means, it'd be a t-test. P, which is my parameter, because this parameter is a proportion. So the P is for proportions, not parameter. P is for proportions. If this was means, my parameter would be a mu. The true proportion of all potatoes in this shipment with blemishes. Conditions. Those are my two housekeeping things. Now I'm ready to do conditions. I'm even going to label. I'm going to communicate to the grader, hey, look at me, I'm about to do my conditions. Random it said random sample. And I would probably underline that in the problem so that, again, they see that I noticed that I'm picking up on that. Independent, 10% condition, which is little n, big N. My sample was 500. Now, this sample size has nothing to do with blemishes. It's just all potatoes in shipment. And then normal, that's my LCC, NP, NQ, no hats because I know who P is. So 500 times 0.08 and 500 times 0.02, and that is a 40. And no, no, that's not 0.02. Sorry, the not of 8% is 92%. Sorry, my bad. I was thinking 80%. Sorry. 500 times 92% is 460. And it makes sense that 460 and 40 add up to 510. Those are my conditions. All right, what's next? What's next? Let's see. I need formula. I go to my formula and I get test statistic equals statistic minus parameter over standard deviation. And don't keep going and just replace these with letters. You need him too. So Z equals P hat minus P square root PQ over N, no hats, because I know P and Q. Now let's plug some numbers in. Z equals, all right, now my statistic is the 47 over 500, my P hat. So 47 over 500 minus 0.08 over the square root of 0.08, 0.92 over 500. I go grab my calculator and type this in. Nope, there it is. Okay. So here I go. I have parentheses because I have to corral the top. 47 divided by 100 minus 0.08. Close the top, divide, square root. 0.08 times 0.92 divided by 500. Boom. Nope. Something wrong. What did I do? Maybe you do need parentheses. Let me see if I put parentheses in here, if it makes a difference. Insert parentheses. Nope, too far. Insert parentheses. No, what am I doing wrong? 40? Oh, I did add a 100. What the heck? I bet y'all are just fussing at me. All right, here we go. Let's go back in here and make this a 500 and not a 100. And that makes a heck of a difference. Now, but guys, I knew I did something wrong because I got a z-score that was 32. And there's no way. There's no way. Oh, and by the way, I just proved that parentheses around these two versus no parentheses around these two does not make a difference because I got the same wrong answer. Okay, so type carefully. But again, I knew that I had made a mistake because 32 is not a logical z-score. Okay, so what am I? 1.154. 1.154. Z equals 1.154. Now that's a positive number. Ooh, you know what I haven't done yet? I haven't done my null or my alternate. Let's do that. Null, alternate. My null is that my proportion of potatoes is 8%. What's he saying? Producer funds more. So we need to test greater than, because if it's greater than 8%, they're going out. Okay, so if this is greater than, and that's a positive z, see how that makes sense? Because this is going to be right-tailed. So it makes sense that my z is positive. So, curve, 0, z. Now, this z is a relatively small z, which means I'm going to have a lot of areas. This p-value is going to be kind of on the big side. So here we go, normal, I can't see, df, from 1.154 to infinity, 0, 1, because we're z's, and I get a p-value, again, label what you're getting. I got a p-value of 0.124. Guys, that's 12%. That's large. Very, very, very large. Now, again, think about what the p-value is. The p-value is the probability that you get a truckload of potatoes that have greater than 8%. 8% of them have blemishes. The fact that that can happen by chance is 12%. So the probability that I get a random truckload of potatoes, and I take a sample, and that sample has more than 8% blemishes, there's a 12% chance of that happening. So check it out. My alpha is at 5%. My p-value is up here at 12.4%. Okay, so now I'm going to write my conclusion, which you should have already done. So you should just be checking yourself. So I'm going to type. So here I go. Since our p value is greater than the level of significance for this test, which is alpha, we fail to reject H sub O. Now, you can say we accept H sub O. I'm going to say we fail to reject, but accept is fine, okay? So we fail to reject H sub O, which means there is not, you don't have to all caps that, I'm just emphasizing, there is not enough convincing, I can't ever spell this word, evidence, oh, I didn't spell enough, sorry, convincing evidence that the shipment contains more than 8% blemished potatoes. All right, so again, I reject or I fail to reject my H sub O, but the evidence statement is always about your H sub A. There is not enough convincing evidence to say that the shipment contains more than 8% blemished potatoes. And this is what my H sub A is saying. So there's not enough evidence to go with H sub A. Now, because I didn't have enough evidence, the data is not statistically significant. There's your 3 sentences. Okay. Last full FRQ. Non-smokers. According to the Centers for Disease Control and Prevention, CDC website, 50% of all high school students have never smoked a cigarette. Susan wonders whether this national result holds true in her large urban high school. For her AP Stats class project, Susan surveys a simple random sample of 150 students from her school. She gets responses from all 150 students, and 90 say that they have never smoked a cigarette. What should Susan conclude? Give appropriate evidence to support your answer. All right. dive in. Pause me and dive in. All right, here it is. You are a one sample z-test for proportions. P is the proportion of all students at Susan's school who would say they have never smoked cigarettes. My conditions: random, simple random sample, independent, 10% condition, 10% condition, N, and then 150 is my sample size, 1/10 of all students at her school. LCC for normalcy, NP and NQ, no hats. There we go. 50% because that's what she's claiming. Or that's what the Center of Disease Control is claiming. My H sub O is that P is 50%. Now, the H sub A, I'm interested to know how many of you caught that it was a not equal to. There's nothing in here suggesting that Susan thinks that this is too high or that it's too low, or that her school is going to be higher or lower than what the CDC is claiming. So we're just claiming that it's different. Susan wonders whether this national results holds true in her large urban high school. Holds true or is false. Then I've got words, letters, numbers, z-score. P-value. Now, this z-score is positive, but remember there is also a negative one down here. So I'm going to do 2 times normal CDF, and I chose the positive one to positive infinity 0.01. So my p-value is 0.0143. Again, I went 4 decimal places. I'm stating my alpha as a 0.05. I'm assuming that it was not stated in the problem, so I'm stating that my alpha is a 0.05. It would have been better if I had stated that way up at the top, probably under my null and my alternate, so that it doesn't appear that I chose my alpha after I did the problem. Now, my p-value is 1%, my alpha is 5%, so my p-value is below my alpha. So my sentence, because our p-value is less than alpha, which is the significance level for this test, we reject H sub O. We have enough convincing evidence to state that the proportion of all students at Susan's school who say they have never smoked differs from the national average of 50%. My data is statistically significant. If there's any piece of that that you have a question about, star it, highlight it, do something so that you can ask me in class. Okay, now I just want to make sure that you understand what information is given to you when you have one of these mini tabs. And I'm sure you probably cannot read it on yours. So let's look at mine. It says, where's the null and the alternate? All right, if you'll look, here it is. P is 0.05 versus P is not. So my null is P, or not 0.05, just 0.5. And my alternate is that P is not 0.5. Check my conditions. Random, you would have to assume that here. There's nothing in here that tells you that it's random. Independent, okay, so 10% condition. N is less than or equal to 1/10 of big N. Well, there's my sample size. So 150 is less than or equal to 1/10 of whatever your population is. And normalcy is the LCC. NP is greater than or equal to 10, and Q is greater than or equal to 10. Well, my N is 150, And my P stays right there. It's 0.5. What is your sample size? 150. What is your parameter? What is your statistic? Okay. Well, I know it's going to be something out of 150. Now, this is the part that's not labeled like Captain Obvious. See that X right there? That's the number of successes. So that's your top number. So 90 out of 150 is your statistic. And p-value tells you way down there, 0.014. Level of significance. Okay, now this one's not super obvious. Check this out. Your level of significance, do y'all see this part right here? It's giving you a 95% confidence interval. Well, think about that. If you have a 95% confidence interval, then how much is outside the wings? 5%. That's alpha. That's alpha. It's the part that's not included in your significance level. Or, I'm sorry, in your confidence interval. So alpha equals your 1 minus your confidence interval. So it was 1 minus a 0.95, and that's where the 0.05 came from. Okay, then the last thing we need to talk about real quick is the power of a test. This is just something you have to memorize. Alpha is the probability of a type 1 error. All right, now that's connecting two things that you already know. Alpha, which is your level of significance for the test, is the probability of a type 1 error. Think about what a type 1 error is. Okay, now alpha is the probability that that will happen. Beta, which you don't know, beta is the probability of a type 2 error. And here's how you find beta. The power is 1 minus beta. So then I can rearrange that and solve for beta if I want to. Or you just memorize one formula. Don't memorize both of them. But the power of a test is 1 minus the probability of a type 2 error. Well, that's beta. So the power of a test is 1 minus beta. So I can give you the power, and I want you to be able to find beta. I can give you beta. I want you to be able to find me the power. It's just a formula. No big deal. Alpha is the probability of a type 1 error. Beta is the probability of a type 2 error. You read that a statistical test at a significance level, alpha equals 0.05, has a power of 0.82, where the probabilities of a type 1 and type 2 error for this test. Well, type 1 probability is alpha, 0.05. Type 2 is beta, which is 1 minus the power. So 1 minus 0.82, which is 0.18. You read that a statistical test at the 1% significance level has a probability of 0.17 making a type 2 error when a specific alternative is true. What is the power of this test? Well, power is 1 minus beta. Beta is the probability of making a type 2 error. That is 0.17. So the power is 1 minus 0.17, which is 83%. So the power is 83%. Don't stress yourself out over this. You need to know alpha, type 1, beta, type 2, and you need to know that formula. That's it. These are going to be like little rinky-dink multiple choice questions. That's it. You will practice enough of them, you'll be fine, but you do need to memorize this up here that's in red. Okay? All right, that's all she wrote.